Good day. I present to you a summary of a video on the lecture we had on population projection and estimate. Now, one would ask, why do we do population projection and estimate? We do population projection and estimate for two reasons. First, to be able to project the population into the future. So we could use this estimate to project Ghana's population into 2030, 2040, 2050. We'd also do that to be able to estimate the population figure in the absence of censuses. Now, there are two main classifications as far as population projection and estimates are concerned. We have what we call intercensal estimates, and then post-censal estimate. Now, when we are doing intercensal estimate, we normally use two population figures. So here, we could use Ghana's population figure of 2010 and 2000 to do what we call intercensal estimates. When we are doing post-censal estimates, we just need one population figure. So we could use Ghana's population census figure of 2010. Now, what are the types of population projection and estimate? We have two main types. We have the component growth method. So types. Component growth method and what we call the population growth rate method. This is an example of what we call intercensal estimate. And this one is a post-censal estimate, post. And this one is, and most of them are intercensal estimates. Now, under population growth method, we have four main methods we do here. Four. The first one is what we call the absolute growth method. The second one is called relative growth rate method. The third is what is known as geometric growth rate method. And the final one is the exponential growth rate method. Now let's pick each method one by one and discuss them. The first one we would like to look at is the component growth method. The component growth method. In the component growth method, the formula we use here is the population to be projected should be equal to the current population figure plus birth within the period minus death within the period plus those coming in, immigration, those in, minus those exiting, emigration. So, in actual fact, if you are going to project or estimate the population for 2020, then for this method, we will say population of 2020 is equal to population of 2010, because that's the current one we've done in Ghana, plus birth over the period minus death over the period plus those moving into the country, immigration, and those exiting out of the country will be deducted to get the population estimates we are looking for. Now let's go on and look at the next method, which is the growth rate method. And there, the first one there is the absolute method. The absolute growth rate method. And this method will look at the change in population. So here, the change in population is actually given by population 2 minus population figure 1. To explain it further, we could say that change in population could be equal to the population Ghana obtained in 2010 minus the population Ghana obtained in 2020. So the 2010 population figure in Ghana is somewhere around 24.6 million, and that of 2000 is 18.9 million. When you subtract this, you are likely to get somewhere around 5.3 million. 5.3 million. So here you would say that Ghana's population increased by 5.3 million people from 2000 to 2010. From 2000 to 2010. Now let's move on and look at the relative growth method. In the relative growth method, all that we say is this. So relative growth rate method, that is RA. So RA is given by the current population over the old population. So here RA is equal to Ghana's current population figure is 2010, and the old one can be population 2000. So RA here is 24.6 million over 18.9 million, and that will give you roughly 1.28, approximately 1.3. So here you would say that Ghana's population in 2010 is approximately 1.3 times greater than that of Ghana's population in 2000. Let us now look at the geometric growth method, the third one. So in the geometric growth rate method, here the formula we use is the population to be estimated should be equal to the current population times 1 plus the rate raised to a power the years interval that could be represented by n or t. Now here this equals population to be projected. This one equals current pop. R equals rate, and N, or sometimes you can use T, equals time, and it is measured in years. But before you calculate this, you need to find the rate, because in all examples you'll be given all the population, and from the population figures you could calculate the time, but the rate will not be given. So in order to get the rate, you need to make R the subject here. So see how we make R the subject. So in making the R the subject here, you first of all need to divide this equation through by PO. So here PO equals PO into bracket 1 plus R n over PO. This and this will go away. So you get Pn PO equals 1 plus R n. In order to take this n2 away, you have to multiply this side by a power of 1 over n and do same here, 1 over n. So this will cancel this. So you'll be left with, so here you have Pn over PO raised to the power 1 over n equals 1 plus R. So you have to take the 1 from the R, and when you do that, it will look like this. R equals Pn over PO. This equals minus 1. So this is the formula for finding the rates, and this is the formula for finding the projected population when you are using geometric growth method. Now let us briefly move on and look at the exponential method. In the exponential method, the formula is exponential growth method. The formula is Pn, population to be projected, equals PO ln Rn. The terms are all the same as explained earlier. So once again, this is for the projected population, but you need to find R, because always R will not be given. So in order to find R, you have to make R the subject in this particular equation. So before you can get R, the first step is to divide through by PO. So PO over Pn over PO equals PO Rn over PO. This will cross this as usual. So you have Pn PO equals ln. This is ln, it's on the calculator, ln. So in order to take away this ln and bring this power down, you have to find the ln of both sides. So here become ln Pn PO equal, the moment you find ln here, this thing will descend and the E will go away. Get Rn. To make R the subject, you need to divide here by n, divide here by n. This will go here. So finally, you will get R equals ln Pn over PO all divided by n. And this is your formula for finding R when you are dealing with exponential growth. Now, we are going to pick one example in the textbooks and work using both the exponential and the geometric growth rate. So let us pick this example. Let's pick this example. The example in page 88. In the example in page 88 in the textbook, we have the population for 1970 given. So population 1970 given as 8.6 million. That for population 1984 was given as 12.2 million. Then you were asked to project for population for 2000. That wasn't given. And those were the parameters given. The R was also not given. We don't have T, was not given. So in this equation, we'll use these two figures to calculate the rate. And here, between these 2 years, we have the time t to be equal to 14 years. And when we get here, we use from here to here to calculate the population itself, the PN. And here we have the time to be equal to 16 years. The 14 years is from 1970 to 1984, 14 years. And the 16 years is from 1984 to 2000. So, without wasting much time, let's now see how we will go about it. First, using the geometric rate. So, in using the geometric rate, the formula says geometric rate. The formula says P, so we are looking for 2000. P 2000 should be equal to P 1984 into bracket 1 plus R, then here is N. And the formula for finding rate, we were told is simply P, so this one use 84, P 1984 over P 1970 minus R minus 1 raised to the power 1 over N. So we are using these two formulas to work whatever we work now. So let's start from the rate. And in starting from the rate, so we have rate equals population of 1984 is 12.2 over 1970 8.6. The difference, the time difference is 14 years. 14 minus 1. So when you work out this, that's what you are going to get. When you work out this alone, this is 1 over 14. Here, you get 1.41860456. 1 over 14 minus 1. R should be equal to, so 141860456. Here, when you change here, you are going to get 0.0714 minus 1. 14 minus 1. And finally, if you work out all this, you will be getting somewhere around 0.025, or R equals 2.5%. However, this is what you use to estimate the population. So now let's go and then put it in the actual formula for geometric rate, and let's see how it will go. So in the geometric estimate, we said the formula is the population we are projecting, which is population of 2000. The current one in the question is population of 1984. We have here to be 1 plus the rate. In the rate, we are going to substitute the rate. It was 0.025, and here, if you look at the years from 84 to 2000, is 16 years. So here we get population 2000 equals That one is 12.2 1 plus 0.025 16 years, and all when you calculate all supposed to give you 18.1 million. So in effect, the population of Ghana in 2000 is supposed to be 18.1 million per the geometric rate. Now let's briefly look at the exponential rate. The exponential growth rate. That one, the formula is given by the population to be projected equals to the current lean Rn. Once again, we need to find R. And in finding R is simply R equals lean Pn over Po all over N. So this is the formula for projecting the population, and this is the R. So first of all, we are going to look for the R and then substitute it in the calculation. So here R equals to lean. Lean is on your calculator. Here is population for 1984 over population 1970 divided by N. The N is time, and this time between the first 1984 1990 is 14 years. So when you calculate, get R to be equal to the same way we got in the first example. In actual fact, you get 0.0249. Approximately you get 0.025, and that is 2.5% to be the rate. Now let's go and slot that equation in the actual formula to project the population. So population 2000 equals that of 84. 84 is 12.2. Your lean will come, your R is 0.025, and between 2000 and 84 it's 16 years. I'm 16. And when you do everything, you are supposed to get somewhere around, you would be getting somewhere around 18.2 million people. Now there's another aspect that you need to know. When will the population be doubled? Doubling time. Call it doubling time. Doubling time. The formula is simple. Time is, I said it is, time is either N or T. So N is simply given by lean 2 over R. So here we know the R already. So here N equals lean 2. The lean is on your calculator. R is 0.025. When you calculate this, you are supposed to get somewhere close to about 27 years. Yes, 27.7258 years. So approximately 28 years. So in 28 years time, the population is supposed to be doubled. So the reference point is from 1984. So let's see how it will double. Let's see the year. 28 years time. So from 1984 plus 28 years roughly give you up to about 2012. And if 1984 population is 12.2 million, then you need to double it. They say it to be double, so you need another one, double, and that will give you 24.4 million. So in actual fact, 2012 population is supposed to be close to about 24.4 million people. Thank you very much and have a wonderful day.